Throughout Earth's history, life has evolved in strange and extraordinary ways. On Deep Space, we explore the wonders of prehistoric life, including the fierce survival battles of creatures before the dinosaurs. During the Paleozoic era, unique creatures with bizarre body shapes thrived. But this period ended with a catastrophic extinction event that wiped out most species. However, a few survivors paved the way for the Mesozoic era, the age of the dinosaurs. Life before the dinosaurs, the Paleozoic era. Before the appearance of dinosaurs, life on Earth was both diverse and strange. The Paleozoic era, roughly 541 to 252 million years ago, is a significant chapter in Earth's history, during which many evolutionary breakthroughs occurred. At the dawn of this era, Earth was a strange and unfamiliar place. The Cambrian explosion, which occurred around 541 million years ago, marked an explosion of life forms, many of them bizarre, with hard exoskeletons and strange body structures that evolved to adapt to various marine environments. During the Silurian and Devonian periods, life began to transition onto land. The first vascular plants, with roots, stems, and leaves, began to colonize the terrestrial environment, creating the first true forests. Alongside them, arthropods like millipedes, scorpions, and the first insects started to diversify and take advantage of new ecological niches. The Devonian also saw the appearance of the first tetrapods, vertebrates that walked on land, including early amphibians. This diversity, however, faced sudden challenges, with mass extinction events such as the End Ordovician and late Devonian extinctions reshaping ecosystems. Despite these challenges, life continued to adapt and evolve in astonishing ways. In the Carboniferous period, the Earth's atmosphere was rich in oxygen, supporting the growth of massive insects and amphibians. The world was lush with swamps and forests, giving rise to the first reptiles, an important step towards the rise of the dinosaurs. However, it was the Permian period that saw Earth's ecosystems grow increasingly complex and diverse, setting the stage for the rise of the dinosaurs. The Permian-Triassic extinction, also known as the Great Dying, fundamentally changed life on Earth, opening ecological niches that allowed dinosaurs to dominate in the coming Mesozoic era. The rise of the dinosaurs in the Mesozoic era, a new dominance. The Mesozoic era, 252 to 66 million years ago, is often referred to as the Age of Dinosaurs, and rightly so, as it witnessed the rise, evolution, and eventual extinction of these magnificent creatures. The Mesozoic is divided into three periods: Triassic, Jurassic, and Cretaceous. By the beginning of the Triassic period, the Earth had begun to recover from the mass extinction events that had devastated life at the end of the Permian. Dinosaurs evolved from earlier reptilian ancestors, adapting to a wide variety of ecological niches. Dinosaurs were incredibly diverse, ranging from small, agile predators to massive, long-necked herbivores. They developed unique adaptations such as bipedal locomotion, complex teeth structures for processing different diets, and defensive behaviors, including powerful tails and armor-like skin. Some of the most important evolutionary developments of the Mesozoic era were the emergence of bird-like dinosaurs and early mammals, although these mammals were small and often lived in the shadows of the dinosaurs. The Triassic period, the dawn of the dinosaurs. The Triassic period, which lasted from about 252 to 201 million years ago, marks the beginning of the Mesozoic era and the rise of dinosaurs. After the Permian-Triassic extinction, the planet was in a period of environmental recovery. Early dinosaurs were small, relatively unspecialized creatures, but they quickly adapted to the changes in Earth's ecosystems. The Pangaea supercontinent was a key factor in shaping the climate and biodiversity of this time. The great deserts and vast tropical regions of the Triassic encouraged the spread of reptiles, including the first pterosaurs and marine reptiles. Some early dinosaur groups, such as theropods, which would eventually give rise to birds, and sauropodomorphs, precursors to the massive sauropods, were becoming increasingly dominant. The Triassic is also notable for the appearance of the first mammal-like reptiles, which would eventually give rise to true mammals in the Jurassic. The Great Dying, a catalyst for evolutionary change. The Permian-Triassic extinction, which occurred around 252 million years ago, remains the most significant mass extinction event in Earth's history. This extinction event decimated 96% of marine species and 70% of terrestrial species, reshaping life on Earth. The causes of this catastrophe are still debated, with theories suggesting volcanic activity, changing atmospheric conditions, or even asteroid impacts. The Great Dying set the stage for the rise of new species and ecosystems in the Triassic. With so many ecological niches suddenly available, surviving species were able to diversify and adapt. This period of rapid diversification is known as adaptive radiation. As a result, the survivors of this event gave rise to many new forms of life, including the dinosaurs, who would dominate the planet for millions of years. Adaptive radiation, evolution's fast-track mechanism. Adaptive radiation is an incredibly powerful concept that explains how rapid diversification occurs after mass extinction events. As species evolve to fill ecological gaps left behind by the sudden disappearance of other organisms. This evolutionary vacuum allows for the swift spread of different life forms that take advantage of newly available resources and unoccupied ecological niches. In the case of dinosaurs, following mass extinctions such as the end of the Permian and Triassic periods, which wiped out a large percentage of life on Earth, new opportunities arose for species to evolve and diversify quickly. Dinosaurs became the dominant terrestrial vertebrates within a few million years, with early species filling ecological roles ranging from top predators to giant herbivores. But dinosaurs weren't alone in this adaptive radiation. Flying reptiles like pterosaurs and marine reptiles like ichthyosaurs also evolved rapidly in response to new environmental niches. Early mammals, though still small and nocturnal, began to evolve as well, showing that adaptive radiation wasn't limited to dinosaurs alone, but was a global phenomenon that shaped many life forms. This phenomenon is not only pivotal for understanding dinosaur evolution, but is also essential for grasping how life on Earth rebounded after extinction events. It showcases the adaptability and potential of life to rebound, diversify, and evolve in new ways after large-scale crises. Early dinosaurs and their evolutionary paths. The early dinosaurs were, in many ways, quite different from the iconic giants that we often associate with the Mesozoic era. These first dinosaurs were small, nimble creatures that often walked on two legs, bipedal, and were built for speed and agility rather than sheer size. They were opportunistic, filling various niches as the ecosystems of the Triassic period were still evolving. These early species did not have the massive sizes or specialized traits seen later, but were already exhibiting important evolutionary steps, such as improved locomotion and predatory adaptations, which would lay the foundation for the large, diverse dinosaurs that followed. As the Mesozoic era progressed, the evolution of dinosaurs took an extraordinary turn with the emergence of sauropods, herbivorous giants that could exceed 100 feet in length. The increase in size was a direct response to the availability of vast food resources such as plant life in the newly forming forests. The development of specialized body structures, like long necks, allowed sauropods to feed on treetops and foliage that other herbivores could not reach. While dinosaurs were rapidly diversifying, early mammals were quietly evolving. These mammals, typically small and nocturnal, lived in the shadows of the dinosaurs. However, they began to adapt to various ecological niches, developing specialized traits such as nocturnal vision and, eventually, more complex brain structures. Though mammals wouldn't dominate the planet until after the dinosaurs' extinction, this period marked an important evolutionary path toward the creatures we recognize today. Overall, the early stages of dinosaur evolution were foundational for the incredible diversity that would follow. The rise of large herbivores and top predators signified a shift in the dominant forms of life on Earth, changing the planet's ecosystems forever. The Jurassic period, the golden age of dinosaurs. The Jurassic period, 201 to 145 million years ago, is often referred to as the golden age of dinosaurs because it marked the peak of their dominance and diversity. During this time, Earth's climate stabilized, which allowed ecosystems to thrive, and the supercontinent Pangaea began to break apart. This splitting of Pangaea led to the creation of new oceans such as the Atlantic and the division of landmasses into separate continents. This geological change created isolated ecosystems and new environments that spurred the evolution and diversification of dinosaurs. Herbivorous dinosaurs, such as the long-necked sauropods, e.g., Brachiosaurus, Apatosaurus, were some of the largest creatures to ever walk the Earth. Their long necks were a key evolutionary adaptation that allowed them to access food sources that other herbivores could not reach, such as the treetops of forests. This adaptation enabled them to survive in an ecosystem where food was plentiful, but competition for low-lying plants was fierce. On the other hand, carnivorous dinosaurs like Allosaurus flourished during the Jurassic. These large theropods had specialized teeth and powerful jaws that made them efficient predators, occupying the top of the food chain. Their ability to hunt and capture a large prey, combined with advanced hunting strategies, gave them an edge in the competitive Jurassic ecosystems. Additionally, the first birds emerged from small feathered theropods. The most famous of these early birds is Archaeopteryx, a small winged dinosaur that displayed both dinosaur and bird characteristics. This is considered one of the most significant evolutionary transitions, as it marks the shift from non-avian dinosaurs to the avian line, ultimately leading to modern birds. The Jurassic skies were also inhabited by pterosaurs, large flying reptiles with wingspans that ranged from a few feet to over 30 feet. These creatures helped fill the ecological niches for large flying predators and herbivores, and their presence in the air added another layer of biodiversity to the already rich terrestrial ecosystems. The Jurassic period, with its complex and diverse array of species, represents the height of dinosaur dominance on Earth, setting the stage for further evolutionary changes in the Cretaceous period. In summary, the Jurassic period was a time of extraordinary evolutionary developments, with dinosaurs reaching their peak in terms of size, behavior, and ecological dominance. The rise of birds and flying reptiles further expanded the biodiversity, shaping the ecosystems that would continue to evolve in the following periods. The Cretaceous period, the final chapter of dinosaur reign. The Cretaceous period, 145 to 65 million years ago, was the last stretch of the Mesozoic era and witnessed the final evolutionary developments of the dinosaurs. This period was marked by the further splitting of continents, leading to the formation of oceans like the North Atlantic and the Indian Ocean, which created new marine and terrestrial environments. The Cretaceous saw the rise of some of the most famous and fearsome dinosaurs, such as the massive Tyrannosaurus rex, the herbivorous Triceratops, and the swift predatory Velociraptor. These species were at the peak of their evolutionary potential, displaying advanced features like highly specialized teeth, complex social behaviors, and effective predation strategies. Flowering plants, angiosperms, began to dominate the landscape during the Cretaceous, replacing the earlier coniferous forests. This evolutionary development provided new sources of food for herbivorous dinosaurs, which, in turn, influenced the evolution of various animal species, including the rise of large plant-eating dinosaurs. However, the Cretaceous period ended with one of the most significant extinction events in Earth's history: the Cretaceous-Paleogene (KG) extinction. This event eradicated roughly 75% of all species, including the non-avian dinosaurs, signaling the end of the dinosaur-dominated era. The Cretaceous-Paleogene extinction, the end of an era. The KPG extinction event, which occurred around 66 million years ago, is widely believed to have been caused by a massive asteroid impact near what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. This impact released an enormous amount of energy, triggering wildfires, tsunamis, and a massive release of sulfur dioxide and dust into the atmosphere, leading to a nuclear winter-like effect. The prolonged darkness that followed the impact significantly disrupted photosynthesis, collapsing the global food chain. Herbivores, unable to find sufficient food, perished, which in turn caused the carnivores to lose their prey. As a result, the majority of the planet's species, including the non-avian dinosaurs, went extinct. This mass extinction was pivotal in shaping the future of life on Earth. It allowed for the emergence of mammals as the dominant land animals and set the stage for the evolution of birds, which are the only surviving descendants of the dinosaurs. The rise of mammals and the Cenozoic era. With the dinosaurs gone, mammals rapidly diversified in the Cenozoic era, 66 million years ago to the present. This era saw the emergence of mammals in all shapes and sizes, ranging from small rodent-like creatures to the towering megafauna, such as mammoths and saber-toothed cats. Mammals' ability to adapt to a wide range of ecological niches, whether terrestrial, aquatic, or aerial, allowed them to thrive. The Cenozoic also witnessed the evolutions of early primates, eventually leading to the emergence of humans. This period is also significant because it marked the appearance of many modern animals, such as horses, bats, and whales. The legacy of dinosaurs in the modern world. Although the dinosaurs are long gone, their legacy lives on in modern birds. Birds are direct descendants of small theropod dinosaurs, retaining many characteristics from their ancestors, such as feathers, hollow bones, and an advanced respiratory system. The study of birds provides scientists with valuable insights into dinosaur behavior, physiology, and evolutionary history. In addition to birds, other prehistory survivors, such as crocodiles and sharks, have shown remarkable resilience and stability, remaining relatively unchanged for hundreds of millions of years. Their survival serves as a reminder of the complex and interconnected evolutionary processes that continue to shape life on Earth. What if dinosaurs had survived? If the KPG extinction event had never occurred, it is possible that dinosaurs would still be the dominant life forms on Earth. In this alternate scenario, mammals, if they evolved at all, would likely have remained small and less diverse. It is even conceivable that intelligent dinosaur species might have evolved, potentially leading to a parallel evolution of technologically advanced beings. However, because of the unpredictable nature of evolution and the numerous variables involved, it is impossible to know for certain how life would have unfolded. What we do know is that the extinction of the dinosaurs paved the way for the rise of mammals and the eventual appearance of humans, fundamentally altering the trajectory of life on Earth. The story of Earth's prehistoric past is one of constant change, adaptation, and survival. The rise and fall of dinosaurs serve as a reminder of the planet's ever-evolving nature. Though their reign ended millions of years ago, their impact on the world remains evident in the life forms that followed. The study of dinosaurs and prehistoric life not only reveals Earth's history, but also provides clues about the future of our planet and the life that inhabits it.